Hi everyone. Today I'm gonna show you ModelFoundry, a tool for DNN decomposition to support on-demand model reuse. When building a software system, usually, we reuse some of the code from the existing system. However, not all of the code is useful, and reusing all of it would incur additional overhead. We choose to reuse some of the code that is relevant to the requirements and delete the code that is not useful. In deep learning models, we also want to be able to reuse only the parts that are relevant to the requirements, as a way to reduce the overhead of model usage. However, unlike code, a deep learning model is a black box. We would like to use only a portion of the functionality through model decomposition. Let's start with a story. Suppose you need to recognize if the current picture has a horse in it. Typically, you have two options. First, build your own model for recognizing pictures containing horses, which takes a lot of time. Second, it is relatively smart to reuse a multi-classification model in which a certain part of the functionality can recognize pictures containing horses. However, reusing the entire model incurs additional time and computational overhead. Therefore, the best choice is to reuse only the part we need, as shown in the figure, not the whole model. In addition, for algorithm integration, we automatically add a mask layer and a head layer to the model through a script, which allows ModelFoundry to adapt to new models with 2 lines of code. We have created a tool named ModelFoundry to enable deep learning model decomposition and on-demand reuse. Let's refresh this interface. ModelFoundry has 3 main functions: module search, model decomposition, and module reuse. The first interface is search modules, which allows the user to search for the desired modules. It is worth noting that, when the search is over, the card below will show multiple contents. Due to the fuzzy search, we return all relevant cards. For some seemingly irrelevant cards, this is because it belongs to the superclass category. We searched all its subcategories and returned the corresponding superclass label. Below the card it shows which dataset this class name comes from. Let's click on this card and ModelFoundry will jump to the model decomposition interface. In this interface, the user can select the class of the model, as well as the model decomposition algorithm. It's worth noting that because we selected the module class in the previous interface, the dataset and target class are frozen here. Here, we can adjust the hyperparameters of the model decomposition. For the 2 different decomposition algorithms, the characteristics are slightly different. For SEAM, ModelFoundry performs the model decomposition by clicking on the Modularize button. Since this process takes a long time, we skipped it. Results such as the accuracy of the module and weight retention are shown here. By clicking the Download button, ModelFoundry downloads the decomposed module for further development. For reuse of modules, we gave an example. Given a module, we can use this module for reasoning. For grad splitter, clicking Modularize performs the decomposition of multiple models, which is a long process that we skip. By clicking the Download button, ModelFoundry downloads the decomposed module to be used for further development. For module reuse, by clicking the Module Reuse button, ModelFoundry evaluates all the decomposed modules of the model at the moment, and selects the modules with the highest accuracy rate for each category, combining them into a more accurate model. Due to structural limitations, this feature is currently only available for some of GradSplitter's modules. That's all the demonstration about ModelFoundry. Thank you.